right, welcome back, guys. Bear with me on this one. If you notice, we're on Module 2, Lesson 7 through 9. So we're going to try to go ahead and cover 3 lessons in this one video. So it might get a little lengthy, but I think it's going to save us some time overall. So in these 3 lessons, we are going to be sequencing translations, reflections, and rotations. So they're the 3 basic rigid motions, the 3 transformations that we've really been looking at lately, and now we're going to sequence them. So think about when you sequence something, or when you've heard the term sequence. You use it a lot in language arts. What it means is we are going to be doing one transformation followed by another transformation. So the first part of this lesson, we are going to be sequencing just translations. So in this first part of it, we're going to be looking at just translations and being able to sequence those and what happens when we sequence the translations. The second part of this lesson, we're going to look at sequencing reflections and sequencing reflections followed by translations, or vice versa. And the third part of it is sequencing rotations. Now we're not going to pay a lot of attention to that, because by the time we do the first and the second one, we're going to know how to do the third one. So not that we're not going to pay attention to it, we're not going to spend a lot of time on it, because you guys are already going to know how to do that part of this. So let's look at the first part of it. Is it possible to translate a figure more than one time? Or can you translate a figure along one vector and then take that figure and translate it along another vector? So if we had 2 vectors, would it be possible to translate it along both of them? Let's find out. So in this picture, we have point P, so the original point P over here. Let me get my pen back out. Okay, so we have this original point P, and we have this original ellipse that we're going to call E. Notice that they're both in black, so we know those are the originals. So the first thing that they did, it says it underwent a sequence of transformations along the red vector. So they went from A to B, that exact distance, that exact direction. So P followed the exact vector to this P prime, the red one. E, same thing, followed that vector to E prime. So went along those 2 transformations that translated it along A to B. Well, now we also have a second vector. We have from B to C. Notice it has to go in that direction. That's where the arrow is going. So they took our new primed ones, our new red ones here, and they translated them from B to C. So they went from point P prime up the length and direction of vector BC, and we got B double prime, E double prime. So we moved it along 2 different vectors. Now, that you know it's possible, now that you know what to do, why don't you try page 33, number 1, parts A, B, and C. It's very quick. Try to translate those figures along more than one line. You can pause now. All right. So that's all for lesson 1. That's it. We're translating that first lesson in this, lesson 7, translating along more than one vector. So we're sequencing translations. So we saw that. It was clear that when you translate along the vector, you could undo the move by translating along the same vector, but in the opposite direction. So did you notice that when you were doing your page 33? Did you notice that if I wanted to go from point P prime back to point P, instead of going from A to B, I would have just translated it from B to A. It would have taken me in that exact same direction. From B to A, the same exact distance. I could have undid that move. So to get from E double prime back to E, I'm going to do the exact opposite. Instead of going A to B, B to C, I'm going to go C to B, B to A, and it would put me right back in that same spot that I started at. So since we know that can happen, can you undo a reflection? So can we sequence more than one reflection? Well, sure. You can reflect it along an x-axis and then along the y-axis, so you could sequence more than one. But could you undo it? What would undo this action? Well, if you're reflecting something, it's just going to be that same reflection again. So if I reflect point A, here over my y-axis, and I get A prime, how could I get back to point A? Yeah, I just reflect it back over the y-axis. So if I have my transparency, I'm going to flip it back, and you're going to get right back to where you started. Okay? Now, the next big question, does the order in which we sequence them matter? So if you go back to that very first transformation, sequence of transformation, these translations, did it matter which order you translated them? Could I have taken E and went up B to C first, and then went from A to B? Would I have still ended up in the same spot? The answer, of course, is yeah, I would end up in that exact same spot. If I went from B to C and then over A to B, I end up still at E prime, which is E double prime, sorry, which is exactly where I was when I went from A to B and then B to C. So the sequence of translation doesn't matter which vector you follow first. But we're looking at a reflection followed by a translation. So we're talking about two different transformations here. So they give us this original E, and they want us first to reflect. So reflect over this line L means I take my transparency, I trace my E, I trace my L, line L, I flip it so that my line L still lays in that same spot. And where you're going to find your reflection is right here. So this right here is the reflection. After I reflect it over line L, that's where it should be if you were to do this on transparency. But now I'm not done because it says a reflection followed by a translation. Notice the sequencing, more than one. So now I have to translate it along vector AB. So now if I take this ellipse and I draw my AB and I slide this down exactly the direction and the distance of A to B, I'm going to end up here. Now this is what I get after I reflect and I translate. The question, though, is would I end up in the same spot if I would have translated and then reflected? So now let's see. Let's see what happens if we translate and then reflect. Well, now I have my original E still, same exact display here. I have E. So first I have to translate it though. Now I'm going to translate it first. So I'm going to take my E and I'm going to translate it. Oops, back here. And I'm going to translate it along A to B. Same direction, same distance. So I end up here. Then I reflect over my line L. So I trace my line L, I trace my translation of E, and I reflect it. Well, then I end up at this one. Is this in the same exact spot on my display as this one was here? And of course the answer is no. This one would be down here somewhere. So it's not whatever order you want to go and you get the same spot. When you are when you're sequencing transformations and you have different types of transformation, order does matter. You need to write that down. It asked that question originally, does it really matter? Yes, when you're sequencing more than one transformation, it really does matter. Is it going to all of the time? No. But because it does some of the time, we just proved that it can matter. It does not end up in the same spot. So you'll always want to follow the order that it gives you. Okay? So, you keeping that in mind, I want you to try page 42. So, were the two figures in the same ending place? Why or why not? So when you do page 42, that's the answer that I want you to have. That's the explanation. Were they in the same ending spot when you translated and reflected as it was when you reflected and translated? And why? We just went over that. So go ahead and pause here and try that for me, please. All right. So now that we've sequenced translations and reflections, what do you think will happen with rotations? Can you sequence rotations? Can you undo rotations? If you rotate it 90 degrees clockwise, is there a way to undo that? So that's what I want you to look at. What if I rotate it and I rotate it more than one time? What happens to the side length? What happens to the angle measures? Do they change? Or what do we know about rotations? Well, you know the answers to those. You know it's a basic rigid motion. You know that the side length and the angle measure stay the same. So go to page 45 and prove that you know that. Try the work on page 45. Okay, so what have we actually learned in this lesson? Well, we learned that you can translate a figure along a vector and then translate it back along another vector, and you get a sequence of transformations. If you translate it along one vector and back along that exact same vector, it gets you back to where you started. We know that regardless of how many translations you sequence together, that the figure's lengths and degrees of the angles are preserved. Doesn't matter how many times you translate it, it's going to be the same. Same thing with the reflection, same thing with the rotation. All of the segments are the same, the angles are the same. It's not going to affect the actual shape, just where it is on the plane. Okay? Please try each of this. I know it was a long one, but I'm confident that you guys can look back through the video, find any of the answers that you need. Whatever you don't have, please be ready to ask that tomorrow. Have a great night.